Okay, let's jump right into this explainer of Setu. What we're looking at today is a seriously fascinating new infrastructure layer built on the Algorand's X402 protocol. Simply put, Setu acts as a secure foundational bridge between autonomous AI agents and the real world of paid services. We're talking about making machine-to-machine commerce safe, automatic, and, inherently trustworthy.
To really grasp how we can safely let machines transact out in the wild, we've got a quick 5-step roadmap today. When AI agents pay, the missing trust layer, the 6 core pillars, real-world AI commerce, and finally the human fallback. Let's get into it.
Section 1. When AI agents pay, or really, the fact that the autonomous economy is already here.
Right. So the autonomous economy isn't some sci-fi concept anymore. It is happening right now. We're rapidly entering a world where AI agents won't just sit in a chat window and generate text for us. They're going to actively buy compute power, call paid APIs, request physical services, and manage logistics, entirely on their own. But before we celebrate this massive leap in automation, we have to ask a genuinely terrifying question. What actually happens when an unchecked AI agent runs wild with a credit card at machine speed?
Our source material hits the nail on the head with this exact quote. The single biggest blocker to agentic commerce isn't the payment rail itself. Honestly, the X402 protocol already solves the basic mechanics of moving the money. The real problem is the absolute lack of foundational trust. Nobody, and I mean absolutely nobody, wants to give an autonomous agent a wallet without a strict spending cap, a reliable way to verify it got what it paid for, and a solid fallback for when automation just isn't enough.
And this perfectly illustrates the 5 massive roadblocks we're currently facing if we want machines to actually buy things. First off, no spending control. A misbehaving agent could literally drain a wallet in seconds. Second, no delivery guarantee. If an agent pays for an API and it returns total garbage, well, the money's already gone. Third, there's no fallback for when automation inevitably hits a wall. Fourth, agents can't even discover services to buy unless they're strictly hard-coded. And fifth, nobody is automatically pricing in real-world externalities, like the massive energy cost of running heavy compute.
Moving to Section 2. The missing trust layer, which is all about building infrastructure, not just another app.
So how do we solve all these insanely complex problems without building dozens of highly specific disconnected apps? Well, Setu is not just a single app or some clever demo. Think of it more like the Stripe Radar or escrow.com of machine-to-machine commerce. It's the underlying horizontal trust layer that makes literally every other agentic commerce app safe to deploy.
Instead of reinventing the wheel and building 11 separate, totally unrelated products for different AI services, one for EV charging, another for translation, another for ride-hailing, Setu solved this by creating one core abstraction engine with pluggable behaviors. Now this brings us to their core insight, which is absolutely crucial. Whether it's an EV charging station or a complex translation API, structurally speaking, they're exactly the same thing, just wearing different clothes. Setu defines this as a listing. It's just a single abstraction where a provider exposes a paid resource, an agent discovers it, pays for it, and, most importantly, expects it to actually work.
Section 3. The 6 core pillars, or how we actually compose this trust layer.
So how is this listing abstraction enforced in the real world? It all comes down to exactly 6 core pillars. Setu relies on these 6 distinct, highly composable building blocks working in perfect harmony to enforce trust, routing, and settlement on the Algorand blockchain.
Looking at the complete architecture, we have, first, a discovery marketplace so agents can actually find services. Second, a spend guard to enforce hard budget caps. Third, an SLA escrow, holding funds until delivery is verified. Fourth, dynamic pricing for when services need to be haggled over rather than fixed. Fifth, green settlement to automatically offset carbon footprints. And finally, sixth, a human fallback queue. These aren't just random features. They're a fully composed architecture.
Okay, Section 4. Real-world AI commerce. Let's see this infrastructure in action.
Theory is great, but let's see how these 6 pillars orchestrate actual real-world machine commerce. Take their flagship listing, for example, the Compute Cooperative. Imagine an AI developer needs some cheap compute. Their agent can hop on the discovery marketplace and find a college lab's idle GPU. Then the agent negotiates the price. Finally, the transaction only settles securely via the SLA escrow once the successful inference output is actually validated. If that GPU fails, the agent gets auto-refunded. Boom, done.
And here's where it gets really cool. Most payment demos force fixed prices, right?
But Setu introduces a multi-agent price negotiation engine. Two agents can literally haggle dynamically based on demand, urgency, and volume, firing counteroffers back and forth in real time before settling the payment. It is a true free market, operating completely at machine speed.
But what if that same agent gets a little too eager and tries to overspend its budget to win the compute? That's exactly where the spend guard middleware steps in. Now, this isn't some gentle little UI warning. It is a hard, real-time, server-side block of an unauthorized payment. The request is flat-out rejected before a blockchain transaction is even constructed.
Let's look at a physical example with the EV Charging Go agent. This shows off true interoperability. An EV's charging agent finds a charger, plugs in, and a live meter ticks exactly per kilowatt hour consumed. It settles continuously via X42. And the absolute beauty here is that the agent can do this across any charging network. It completely eliminates the need for a separate, clunky proprietary app for every single brand of charging station.
What's even more impressive, and honestly a huge win for sustainability, is the built-in green settlement. Because look, AI inference has a massive real-world energy cost. To solve this, Setu uses Algorand's atomic transaction grouping. Every single time a payment clears, a fraction of it is automatically and inseparably split into a verified carbon offset pool on-chain. It offsets the energy footprint at the exact moment of payment. Pretty amazing, right?
Section 5. The human fallback, or what happens when automation hits a wall.
As we all know, AI autonomy has very real limits. Imagine a regional language translation agent. Say it's translating a super rare dialect. It hits a snag because its confidence score for the translation is simply too low to complete the task accurately. Now, in a standard system, the API call just fails, the money might be lost, and the user's left completely stranded.
But instead of failing out, Setu routes that original request over to something called the Community Skill Exchange. It posts the failing job as a micro-task to a fallback queue. A real, live human gig worker can see this task, claim it, translate the audio themselves, and submit the result. The exact same SLA escrow engine then takes over and releases the AI's payment directly to the human worker's wallet, live and on-chain.
I absolutely love this quote from the source spec. It completely flips that standard, gloomy narrative of AI just replacing human jobs. Instead, it proves that AI agents can directly hire and pay humans to bridge the automation gap. It seamlessly blends the agentic economy right into the human gig economy.
So, as Setu lays down the trust infrastructure for this machine-to-machine future, making it safe, reliable, and deeply interconnected, we are left with a seriously fascinating question to close on. As AI inevitably starts controlling budgets and outsourcing its own failures, how will you adapt your skills for an economy where your next microtask is assigned and paid for entirely by an algorithm?